Hi Year 11 and welcome back to these short video clips in preparation for Chemistry Paper 2. Today's session is all about looking at the identification of ions by different chemical techniques. And as you can see, there's a long list of different things we're going to look at in this session. I do want to point out this is a green topic for foundation tier, so therefore there will be a full potential question in and around these things that we're going to look at today. For higher tier, this is amber, so therefore there may be the odd question in regards to it, so also very useful to watch. So what we're going to look at today, we're going to look at the flame test. We're going to talk a little bit about metal hydroxides and how we use different techniques to identify the metal ion contained within those. We're then going to look at the 3 different tests for our negative ions. And then, as you can see, we're going to talk a little bit about instrumental methods and compare them really to these different techniques here. But we might as well just jump in and get started. So we're going to start with the flame test. So as you can see in my diagram, you have got a picture here that starts off with really explaining the technique. Now this is a required practical, so it's important you know about each element and why it has those specific things. So I've seen questions, believe it or not, where they get you to label the equipment. So we have our wire loop, okay, which as you can see I have placed into my substance. So this could be, for example, an unknown metal ion that we don't know, but it is usually a powder. And as you can see, I've then got my Bunsen burner, and that is on a blue flame. And they sometimes ask why. So obviously, if it was on an orange flame, then would you be able to see coloured ions? No. So that's why it has to be on a blue flame. Okay, so you can in fact see the colour. Okay, so it's important that you're aware of that. And as you can see, we take our powder sample, we place it onto the wire loop, and we then place it into the flame, and we observe the colour. Okay, we observe the colour change. Now, a couple of things. You may also dip the wire loop into acid, and that is to remove any excess powder that may already be on the wire loop. And that's important for what we call contamination. Okay, because if you've got contamination on the wire loop, then you might get a blur, a mixture of colours here, so therefore would not be very accurate in terms of a technique. So types of questions they ask around that, hopefully that's helped. So again, it could be labelling equipment, it could be a method to identify an unknown metal ion, and it's important that you're able to identify those steps. So I'll just go through it again. Our wire loop with our unknown powder on it. Remember though, before we dip it into the powder, we have added the wire loop to acid to remove any potential contamination. We turn our Bunsen burner on to a blue flame, and the reason why is so we can observe the colour change. We then take our wire loop with our powder sample and then place it into the Bunsen burner just above the inside cone, as you can see there on the picture, and then we observe the colour change. Now you do need to know the different coloured ions. So as you can see, this is all about our positive metal ions. This is what we use the flame test for. And again, you are expected to know the colours of these different ions. So we're going to go through the colours, and I'm going to hopefully give you some ways to remember the colours. So lithium is what we call a crimson flame. So it's a crimson red flame that you will see. Sodium is a yellow flame. Now, although I know the sun is not yellow, because it is in fact white, but can you see how we see it here on Earth is yellow? So sodium begins with an S, the sun is yellow, that's how to remember sodium is yellow. Potassium, again, is a purpley lilac colour, so it's lilac. And again, P for P, so purple lilac colour. Calcium is an orangey red in colour, and copper is a green colour. Now I often, if I've taught this to you before, you'll know that I've said copper begins with a C, so does Celtic, who I think are the best team ever, and they are green. So that's how you know copper is green. So these are the colours you'd expect to see in a flame test. These are the ones that are on the specification that you do need to know the colour of. And we would use this technique to help us to identify these specific positive metal ions. Now, sometimes our metal ions are actually in solution, and we may therefore want to use a displacement reaction to identify the metal ion. So again, this experiment is our second method that we could potentially use for identifying positive metal ions. So as you can see, this is about what we call metal hydroxides. So if we've got, for example, aluminium, if we then add sodium hydroxide to it, then we can in fact get a displacement reaction going on, and we get what's called a precipitate forming in this solution. So we're going to go through this now. So essentially we use, if you can see that, sodium hydroxide solution. Now you'll know sodium is a really reactive metal, and it's used to identify our metal ions, so our positive ions. You can see from the picture, I've got my sample. So that could be an unknown sample, for example, And then I add, so in this case it's magnesium sulfate. I've added that to our solution. And then I add the sodium hydroxide to that. And as you can see, we form a precipitate. And that precipitate has a specific colour. And you need to be aware of which metal ions form which specific colour. Okay, so we're going to basically go through the method here. So method number one is your sample containing a metal ion. So in this case, as you can see, magnesium sulfate, it could be aluminium sulfate, could be whatever it needs to be. It's poured into our beaker, or sorry, test tube, and then to that we add sodium hydroxide, and then we observe a precipitate forming, and that precipitate would have a specific colour, and as such you can identify the ions. So we're going to go through the different types of coloured ions and then whether or not it would redissolve or not. So aluminium, calcium and magnesium, they form white precipitates. Can you see how they are all the metals that are in fact within the groups of the periodic table? So aluminium is in group 3, calcium group 2, magnesium group 2. So the ones that are in the groups of the periodic table all form a white precipitate. Now, there is only one metal ion that will redissolve. So what we mean by redissolve is you add excess sodium hydroxide. So you're adding more sodium hydroxide after the precipitate is formed. And the aluminium is the only one that will in fact redissolve when you add excess sodium hydroxide. The other two would not. If we then move on to our transition metals, so we'll just put the fact that these are in the groups. Now these here are our transition metals. So they are in the middle block of the periodic table and they have specific colours. So iron 2 forms a green precipitate, iron 3 forms a brown precipitate, and copper this time, not for Celtic, this time they're for Rangers. So therefore they're going to turn blue. Okay, so if we're looking at precipitate tests for metal ions, they are the colours. Again, as I said earlier, aluminium is the only one that does in fact redissolve, so therefore none of the rest do. So they do like to ask about the aluminium, so it's just a reminder that aluminium does redissolve. So we've got groups are white colours, those are the transition metals, green, brown and blue, and again you have to know those colours off by heart. All right, so moving on to so we just looked at the positive metal ions. We're now going to look at our negative ions. So we'll know already that the carbonates look like this, so CO3. Our halides are anything in group 7. And sulfates are SO4. Okay, so 2-. So we are in fact testing for our negative ions. So these are our negative ions that we're testing for. And they all each have a different test that, again, you need to know what the test is and also what the colour is that is produced. So you can see we've got solutions again. So we're looking at precipitation precipitates. So we know that's a solid forming in a liquid, and those precipitates have a specific colour. So we'll start off with the sulfate ions. So our sulfate ion, really straightforward. We add acidified barium chloride. So in other words, the barium chloride contains an acid. It's added to an acid. So we're going to write that test down. So it's essentially acidified barium chloride is our sulfate. And the result of that, as you can see in the picture really clearly, is a white precipitate. So the sulfate ions, acidified barium chloride is what you'd add, and it forms a white precipitate. Our carbonate ions you can't see here because actually we use lime water, because as you can see it contains, or well, if it reacts with an acid, for example, will produce carbon dioxide gas. So essentially what we do is we add our carbonate sample to an acid, we collect the gas that is produced, and then we basically put that gas through lime water. And you should know the test for lime water. That will go a milky white colour, cloudy. Okay, milky white in colour. So that's how you test for carbonate ions. In terms of the halides, so this is our halide group, because as you can see, that is all group 7. So the test is all the same, and all you have to do here is it's basically acidified silver nitrate is how you test for this here. And you then get a colour change depending on where the element is in the group. So you'll know that chlorine is at the top of the group compared to bromine and iodine, so they're above. So basically it's in order as you go down. And that then causes the precipitate to change colour. So chloride ions will form a white precipitate, bromide ions will form a cream precipitate, and your iodide ions form a yellow precipitate. So they're getting darker as you go down the group, and that's, as you'll know, has got to do with reactivity, because reactivity does decrease as you go down the group. But essentially what you need to be aware of is how you test for it. So we add silver nitrate with acid, so acidified silver nitrate. We then add our sample, and as you can see in the picture, we get our different coloured precipitates that are formed. So that's the tests for the negative ions and the positive ions. So what I'd probably do now is pause the video, take a moment, just check to see if you can memorise those different colours, and then test yourself on them, because again, this is one of those sections where actually you just need to know the colours. I'm going to move on to the last part of this section. Again, this is again in both foundation and higher, but as a green topic for foundation. So we're going to look at what's called instrumental methods, and then we're going to look at flame emission spectroscopy. So our instrumental methods are essentially what we call more accurate techniques. So if we just looked at our flame test, for example, we're using a wire loop with adding it to powder and then placing it into flame. That's not very accurate because we're looking at colour observations, so we're looking at qualitative data. So it could be open to interpretation. Instrumental methods are very accurate, okay? So they will in fact produce rapid results, and they're also very sensitive. So what that means is even if you've got really small amounts, you can get a lot of information from that. So these are the 3 things you need to know about instrumental methods. They're more accurate, they're faster in terms of getting results, and we can in fact analyse a very small amount of substance, so therefore they're very sensitive in terms of what they can pick up. Now you need to be able to compare instrumental methods to the ones we've just talked about, which aren't as accurate. So just be aware that you might be asked to compare those. So here's an example of an instrumental method. So this is what we call the flame emission spectroscopy. So I'm just going to write down the fact that this is an instrumental method. So again, very similar to that of the flame test. You can see I've got my sample that I've placed into the flame, and that sample then emits light, and that light then, as you can see in the picture, passes through a spectroscope, and as a result, we produce a spectrum of colours. Okay, now as you can see here, this is what we'd call our spectrum. I've got better pictures of it down here, but we basically produce a different bands of light, okay, which we can then analyse. So this is what we call a line spectrum, okay, and they can use this to identify the ion. So far more sensitive than, obviously, far more accurate actually than a flame test, because I've got a quantitative result here. I've got some bands and lines that I can then compare. So if you look at this example down here, you can see I've got my unknown sample that I want to try and work out which ions might be present within it. And if I've got my known samples, so here you can see I've got 3 different elements in terms of the spectrum of light that they produce, I can then quite clearly see that it does and doesn't contain these specific things. So you can see it's got the yellow, the green, the blue, the blue. Wait a minute. Can you see how actually that doesn't line up there? Okay, and there's no purple there. So I can rule out straight away that actually that one there is not contained within my sample, but this one is, as is this one here. Okay, so you can actually work out from a line spectrum what, from an unknown sample, what elements are contained within it. And I've seen that come up quite a lot with exam questions, so it's important that you are in fact able to do that. There's one last thing I just remembered that I haven't quite mentioned, is about the different hydroxide ion tests. So for example, can you see how here calcium and magnesium both form a white precipitate, but they do not redissolve? So how on earth then can we work out the difference between those two? Well, what you'd have to do is a flame test. So be aware that sometimes if you cannot get the result, you cannot see clearly the result that you need in order to work out what the metal ion is, you may have to do a further test to then be able to tell the difference between these ions, which obviously you couldn't do in this specific test here. So that is everything that we've just gone through. So here's the list of topics, as you can see, our flame test methods and how to do the flame test and testing for different ions, metal ions, that is, positive metal ions, along with their colours. The metal hydroxide test, so again, making sure that you know that they form precipitates that are different colours, that aluminium is the only one that redissolves. If metals are in a group, then they form a white precipitate. If they are not in a group, then they form a coloured precipitate. So iron 2, iron 3, they form green and brown. And then the copper this time is not on the good end, as I call it, the Celtic end. We're now on the Rangers end, so therefore it goes blue. So again, you need to know those colours. If you cannot tell the difference because they both form the same colour precipitate, like a white precipitate, then you would go on to do the flame test. The carbonates, again, you add to acid and then you collect the gas and test it with lime water. It goes cloudy. The halides, you'd add acidified silver nitrate and it then forms different coloured precipitates. And as we talked about, it gets darker as you go down the group. So chlorine is white, bromine is cream colour, and our iodine is a yellow in colour. Our sulfate ions, again, these are all our non-metals. So as you know, that's when you add your acidified barium chloride to that solution and it will form a white precipitate. You need to know what this means. So again, it's about a more accurate, rapid and sensitive technique in order to analyse different chemical ions, identification of ions. And then our flame emission spectroscopy, how that is an example of instrumental methods, but then being able to interpret line spectrums. So hopefully that's helped you out a little bit in terms of the whistle-stop tour of the different types of ion tests. Again, as always, if you've got any questions, please don't hesitate to email me or ask me when I see you in the lesson. All right, thank you.